Good morning, everyone. Welcome back, and it's a Halloween day. Thank you for joining us. Let's get you through this Halloween day. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings. We are the science and technology, not experts, just messengers, in Apple Valley, California.
Yep, and we're talking definitely science today. So this is a cool topic.
This is amazing. I mean, if you are a gamer, online gamer, you know what latency is. You know exactly what latency is. Researchers have developed an optical computing system that performs feature extraction for quantitative trading with unprecedentedly low latency. The latency is what gums up your computer and makes it seem slow, like the graphics and stuff. When you have low, then that means it's moving fast. Many advanced artificial intelligence systems, including those used in surgical robotics, and high-speed financial trading, rely on processing large streams of raw data to identify important features almost instantly. However, traditional digital processors are reaching their physical limits. These electronic systems struggle to deliver the speed and data capacity that next-gen, data-heavy applications demand, resulting in slower performance and higher latency. Well, latency is a bad word. Would you like to know more?
So low is good, high is bad.
Yeah, so on World of Warcraft, if you're pulling 80 milliseconds, it's going slow. If you're around 30 milliseconds, it's like regular normal, looking around, everything's normal. And you're going to see they get into the picoseconds, which is really tiny.
Okay. Researchers believe the key to overcoming these limitations may come from using light instead of electricity. This emerging approach, known as optical computing, uses light to carry out complex computations with extraordinary speed. One of the most promising technologies in this field involves optical diffraction. Operators. Thin plate-like components to calculate as light travels through them.
So back in the day, 30 years ago, whatever, 35, I started out as an electrical engineering student, and I wanted to specialize in optics, and I flunked out, of course, and I went to construction management, but because I couldn't get past networks. But I'm surprised it took this long for optics to develop. I'm really surprised. Right. These systems are highly energy efficient and capable of handling multiple data streams simultaneously. Yet, achieving operating speeds above 10 gigahertz has proven difficult because it requires extremely stable, coherent light, which is challenging to maintain. I don't know why coherent light is challenging. Light is light. It just goes, I don't know.
A team led by Professor Hongwei Chen at Tsinghua University, China, has now developed an innovative solution to this challenge. As detailed in Advanced Photonics Nexus on October 8th, 2025, the researchers created an optical feature extraction engine designed to perform optical-based data analysis across a range of real-world applications.
Okay, a core innovation lies in the optical feature extraction engine, which we're going to call OFE2. Innovation lies in the OFE2 data preparation module, providing high-speed and parallel optical signals for optical cores operating in a coherent environment is highly challenging, as using fiber-based components for power splitting and display delay introduce strong phase perturbations. The team solved this by developing an integrated on-chip system with tunable power splitters and precise delay lines. This module effectively deserializes the data stream by sampling the input signal into multiple stable parallel branches. However, an adjustable integrated phase array allows OFE2 to be configured as necessary.
Once the data is prepared, the optical waves pass through the diffraction operator. The process can be mathematically modeled as a matrix vector multiplication that performs feature extraction. The key to this operation is how the diffracted light forms a focused bright spot at the output, which can be partially deflected towards a specific output port by adjusting the phase of the parallel input lights. This movement and the corresponding changes in output power allow OFE2 to effectively capture features related to the input signal's variations over time.
Operating at a rate of 12.5 gigahertz, OFE2 can perform a single matrix vector multiplication in less than 250.5 picoseconds. Oh my gosh. That is like 10 to the minus ninth picoseconds. The shortest latency among similar optical computing implementations. Quote, we firmly believe this work provides a significant benchmark for advancing integrated optical diffraction computing to exceed a 10 gigahertz rate in real-world applications, says Chen.
The research team successfully demonstrated the capability of the proposed system across diverse tasks. For image processing, OFE2 was able to extract edge features from input images, creating two complementary relief and engraving feature maps. The features generated by OFE2 led to better performance in image classification and increased pixel accuracy in some semantic segmentation, such as identifying organs in computed tomography scans.
Yeah, that is really cool. Notably, the AI networks using OFE2 required fewer electronic parameters than a baseline one, proving that optical preprocessing can lead to lighter and more efficient hybrid AI systems. In addition, the team obtained similar results for a digital trading task where OFE2 received time series market data and proposed profitable trading actions based on an optimized strategy. In this task, traders input real-time price signals into the OFE2.
After prior training, the optimally configured OFE2 generates output signals that can be directly converted into buy or sell actions through a simple decision process, achieving stable profitability. Since the entire process is executed at the speed of light, it offers a significant latency advantage, allowing profits to be captured with minimal delay.
We like that. If you're a Ferengi, it's all about profit. Taken together, these results point toward a new paradigm in which the most intense computational burdens are shifted from power-hungry electronics to ultra-fast, low-energy photonics, leading to a new generation of real-time decision-making AI systems. Quote, the advancements presented in our study push integrated diffraction operators to a higher rate, providing support for compute-intensive services in areas such as image recognition, assisted healthcare, and digital finance. We look forward to collaborating with partners who have data-intensive computational needs, concludes Chen. They better get a trademark for this.
Okay, well, if you're excited about this, good for you, because I have no idea what we're talking about here. I'm not a gamer. I'm not a computer guy. But, I mean, when you talk about Pico, I'm talking about stuff I put on my tacos. So anyway, here we go. Glad to hear it. Steve's excited, that's for sure.
I am, man. All right, thanks for joining us, folks. We'll catch you in the afternoon.
Take care, everyone. Have a good morning.